Hello and welcome to Engineering Simple. In this video, I'll talk about a remarkable identity. These are very important equations in solving problems, such as equations, finding limits, and so on and so forth. So here's the first one. A squared minus b squared is the same as quantity a minus b times quantity a plus b. So let's see if that's true. So I can simplify a times a is a squared, then a times plus b, because I have plus here, is plus ab. Now I can go to minus b times a is minus ba, or minus ab is the same thing. Then minus b times plus b is minus times plus is minus b squared. So notice I have plus ab minus ab, so this equals 0 basically. So I'm left with a squared plus 0 minus b squared. Let me just erase. So minus b squared, which is equal to a squared minus b squared. So it makes sense. So now let's see how we can apply this identity. So what I want to do, these three equations here, I want to write them in the form of a squared minus b squared. Then I can take advantage of this simplification here. So x squared minus 4 squared minus 4. So x is already squared. Minus 4, I want to put it in the form of something squared that would give me 4, which is 2. So in this case, my a is x and my b is 2. So I can write it as a minus 2 times a plus 2. So let's do the same thing here. So I want to write this in the form of a squared minus b squared. So 9 is 3 squared minus 4, which is 2 squared times x squared. I can rewrite as 3 squared minus 2 squared times x squared. I can write it as 1 squared basically. So my a is 3 and b is 2x. So I can write this as 3 minus 2x times 3 plus 2x. So again, I need to write this in the form of a squared minus b squared. So 2 is the same as square root of 2 squared, so times x squared minus 5, which is the same as square root of 5 squared. Can rewrite as, so square root of 2 times x I can write as 1 squared. It's the same thing. Minus square root of 5. So I notice my a is square root of 2 times x and my b is square root of 5. So I can rewrite this as square root of 2 times x minus square root of 5 times square root of 2 x plus square root of 5. And notice the order doesn't change. You can write, so I wrote square root of 2x minus square root of 5 times square root of 2x plus square root of 5. You can also write square root of 2x plus square root of 5 times square root of 2x minus square root of 5. So the order doesn't matter. So now let's go to the next identity. So a squared minus 2 times a times b plus b squared is the same as a minus b quantity squared. So a minus b quantity squared is the same as a minus b times a minus b. Now let's simplify this. So a times a is a squared. A times minus b. So a times minus b is minus ab. Now let's go to minus b times a is minus ba or minus ab. Then minus b times minus b. Minus times minus is plus. B times b is just b squared. So I can simplify further. A squared. So minus ab minus ab is just minus 2ab plus b squared. So these are the same. So now let's see how we can apply this little formula. So what I have to do is I have to write this in the form of a squared minus 2. So I have a 2 times ab plus b squared. Then I can take advantage of writing it as this. So x is already squared. So x squared, so minus 4x. So there is a 2 that it's always there. So minus 2 times something will give me 4, which is 2. So 2 times x, because 2 times x is 4x, which is the same as this. Then I have to write 4 in the form of something squared that will give me 4, which is 2. So notice I wrote this in the form of a squared minus 2 times a times b plus b squared. So in this case, my a is x and my b is 2. So I can go ahead and apply this here. So it's just a minus b quantity squared. So x minus 2 squared. So step 1, I have to write this in the form of this. So 9 is the same as 3 squared. So minus, there is a 2. So 2 times something will give me 30. So 2 times 15, x plus 25 is the same as 5 squared, and x squared is already squared. So 3 squared minus 2. 15 is the same as 3 times 5x plus 5 squared times x squared. I can write it as 5x quantity squared. It's the same thing. So notice here, my a is 3 and my b is 5x. So I can go ahead and write it as a minus b quantity squared. So 3 minus 5x quantity squared. So when you're solving an equation, so let's assume this was equal to 0, for instance. You want to find the values of x that would satisfy that equation. It's very hard to deal with this, and it's a lot easier to deal with this simplification here. And we'll see examples in future. But it's important to understand how to apply these identities. So again, step 1 is rewrite this in the form of a squared minus 2 times ab plus b squared. Okay, so 2 is the same as square root of 2 squared. X is already squared. Then I always have 2. So 2 times something will give me 2 square root of 2x. So it's 2 times square root of 2x plus 1 is the same as 1 squared. So I can rewrite this as square root of x entire thing squared is the same thing. So minus 2 square root of 2x times 1 plus 1 squared. So notice this is my a and 1 is my b. So I can take advantage of writing this as square root of 2x minus 1 squared. So let's go to the next identity. So if we have an equation that's in the form of a squared plus 2 times a times b plus b squared, we can write it as quantity a plus b squared. So this quantity here, a plus b squared, is the same as a plus b times a plus b. So I can simplify a times a is a squared, then a times plus b is plus ab. B times a is plus ba or ab is the same thing. The order doesn't matter. Then b times plus b is plus b squared. So it's important to watch the signs because I have plus b times plus b, which gives me plus. So I can rewrite this as a squared. So plus ab is 2 times ab plus b squared. So we know they're the same. Check. So now let's see how we can apply this identity. So like we saw before, when you have an equation like this, you want to write it in the form of a squared plus 2 times a times b plus b squared. So 36 is 6 squared times x squared plus 24. So there's always a 2. So I'm going to write 2 times something would give me 24, which is 12. And I have x plus 4. 2 squared is 4. And here's 6 squared times x squared. I can write that as 6 quantity squared plus 2 times, so I already see there is a 6 here and there is a 2 here. And I know 2 times 6 give me 12. So I can write this 2 times 6x times 2 plus 2 squared. So notice my a is 6x and b is 2. So a plus b quantity squared, 6x plus 2 squared. So the same thing here. First step, rewrite this in the form of this here. Then you can take advantage of this factorization. So 25 is the same as 5 squared plus, notice there is a 2 here, so 2 times something will give me 10. That's 5. And I have x, so 2 times 5x is 10x. So I didn't change anything. I just rewrote it basically in a different way. Plus x squared. So I can notice here my a is 5 and my b is x. So a plus b is 5 plus x quantity squared. So again, step 1 is rewrite this in the form of a squared plus 2 times a times b plus b squared. So 2 is the same as square root of 2 squared plus, there is always a 2. So 2 times something will give me this. So it's times square root of 2, and I have an x, so basically I didn't change anything. Plus x squared. So as I can see, my a is square root of 2 and my b is x. So I can write it as a plus b quantity squared. A is square root of 2 plus x quantity squared. So now it's another identity. So a cubed minus b cubed equal a minus b times a squared plus ab plus b squared. So let's simplify. So a times a squared is a cubed. Then a times ab plus a squared b. Then a times plus b squared is plus ab squared. Now I'm going to move on to the other side. So minus b times a squared is minus ba squared. Then minus b times ab is minus a b squared. Then minus b times plus b squared, which is minus b cubed. So I can simplify this. So a cubed plus a squared b plus ab squared minus ba squared is the same as a squared times b minus ab squared minus b cubed. So notice here I have plus a squared b and I have minus a squared b, so those go away. Then I have plus, so I'm just going to put two lines underneath. So plus a times b squared minus a b squared, so they're the same. So I'll just rearrange. So a cubed plus a squared b. So this here, and I'm going to move this, so I'm not changing anything, it's just the location. So a squared b basically. Then plus a squared, or sorry, a b squared, this here. So I already moved this. So I have this. So now I did this one, and I already did this one. So minus basically this one here, ab squared minus b cubed. So these are 0, these are 0. So 0 basically is like you don't have anything. So I just end up with a cubed minus b cubed. So this is another very, very important identity to remember. So now let's see how we can apply this. So I have x cubed minus 8. So I have to write it in this form in order for me to use this simplification here. So x cubed is already cubed, minus 8, I know 2 cubed is 8. So notice my a is x and my b is 2. So I can rewrite this as a minus b. So x minus 2, a squared is x squared in my case, plus a times b, x times 2, which is 2x, plus b squared, which is 2 squared, which is 4. So that's it. Because if you're solving an equation, it's a lot easier to deal with this because you have quadratic and you have first order equation versus dealing with cubes. That's why it's important to know these identities. So now I have to rewrite this such that I have something that's cubed minus something that's cubed. So again, 8 is the same as 2 to the power of 3 because 2 times 2 is 4 times 2 is 8. X cubed minus 1 is the same as 1 cubed. then I can rewrite 2x. Since they have the same power, I can just put them under the same power. I'm not doing anything here. So again, my a in this case is 2x and my b is 1. So this equals a minus b, which is 2x minus 1 times a squared, which is 2x squared, which is 4x squared basically, plus a times b, which is 2x times 1, which is just 2x, plus b squared, which is 1 squared, which is just 1. So again, the first step, I want to rewrite this as something cubed minus something cubed. So 27, if I notice 27 is the same as 3 cubed. 3 times 3 is 9, times 3 is 27. Minus 2, so 2 is the same as square root of 2 squared times square root of 2 x cubed. So I can rewrite it as 3 cubed minus square root of 2 squared times square root of 2 is just square root of 2 cubed, x cubed. So I can rewrite it as 3 cubed minus, so since they have the same power here, I can put them under the same power. So it's square root of 2x cubed. So notice my a is 3 and my b is square root of 2x. So I can take advantage of a minus b, which is 3 minus square root of 2x times a squared, which is 3 squared, which is 9, plus a times b, which is 3 times square root of 2x. So 3 square root of 2x plus b squared. My b is square root of 2x, so that squared is just 2x squared. So here's another very important identity. So a cubed plus this time, so the previous one was a cubed minus b cubed. This one is a cubed minus b cubed. So it's equal to a plus b times quantity a squared minus a times b plus b squared. Let's simplify. A times a squared is a cubed. A times minus ab is minus a squared b. Then a times plus b squared is plus ab squared. Then plus b times a squared is plus ba squared. Then plus b times minus ab is minus ab squared. Then plus b squared is plus b cubed. So I can rearrange a cubed minus a squared b. So I'm gonna put a line underneath. So a squared b, and I see here plus ba squared, which is the same as plus a squared b. Basically, I just changed the order. Plus ab squared, this here, minus this one here, minus ab squared plus b cubed. So notice minus a squared b plus a squared b is 0. Then plus a b squared minus ab squared is 0. So I end up with a cubed plus b cubed. Another very important identity. So now let's see how we can apply this. So again, step one, I have to write this in the form of something cubed plus something cubed. So x is already cubed plus 8 is just 2 cubed, because 2 to the power of 3 is 2 times 2 is 4 times 2 is 8. So my a is x and my b is 2. So I can write it as, so a plus b is x plus 2 times a squared, in my case x squared, minus, so minus a times b, so x times 2 is just 2x plus b squared, which is 2 squared. 2 squared is just 4, so plus 4. So again, step 1, I have to write this in the form of something cubed plus something else cubed. And then I can see what is my a and what is my b. So 8 is the same as 2 cubed. X cubed is already cubed, plus 1. 1 cubed is 1. Since they share the same power here, and it's multiplication, I can just write 2 times x cubed plus 1 cubed. So again, I found my a is 2x and my b is 1. So I can write it as a plus b, which is 2x plus 1 times a squared, which is 2x squared, which is 4x squared, minus a times b. 2x times 1 is 2x, plus b squared. 1 squared is just 1. So the same concept, step 1, rewrite this as some a cubed plus b cubed. So 27 is 3 cubed. 3 times 3 is 9, times 3 is 27, plus square root of 2 is just square root of 2 squared times square root of 2 times x cubed. So 3 cubed plus square root of 2 squared times square root of 2. So assume it's like there is square root of 2 to the power of 1. So 2 plus 1 is 3. So then, square root of 2 power of 3 x cubed. So 3 cubed plus square root of 2 times x entire thing cubed. So again, my a is 3 and my b is square root of 2 times x. So a plus b is 3 plus square root of 2 times x. A squared is 3 squared. 3 squared is 9 minus a times b. 3 times square root of 2 times x. So it's just 3 times square root of 2 x plus b squared, which is square root of 2 times x quantity squared is just 2x squared. So these are very important identities to remember and to know how to apply them and do operations around them. So that was it for today's video, and if you want to watch more videos, you can go to Engineering Simple. Thank you and have a great day.